Hello students, today we are going to talk about arc length of a circle. We already know that a circle is created when you have points that are the same distance from a central point and that goes all the way around, so that when we are creating our arcs, we're talking about a portion of it. So here's our circle. And it is created by a series of dots that go completely around this central dot, and they're all exactly the same length, and that is called our radius. Sometimes they are cut by a diagonal, and when they're cut by a diagonal, that is when, or not a diagonal, but from all the way across. So going through the point in the center, from one point on the circle to the other. And that is called a diameter. So there's our quick review of diameter and radius. So the central angle is the angle whose vertex is the center of a circle. So let's say we're talking about this one. So this is my central angle from this radius to this radius. The minor arc is the part of the circle that measures less than 180 degrees. So in this case, it would be from this point to this point. This would be an arc. And a lot of times they are designated by capital letters. And so this would be the minor arc AB. Major arc is one that measures between 180 and 360. So if I were to, let's put a point anywhere on this line and put a C, if I go from this B all the way around to A, this would be my major arc, and it's between 180 and 360. So it's got to be bigger than half the circle. And a semicircle are arcs with endpoints that are endpoints of a diameter. So in this case, let's call this one E. From arc BCE or BE would be considered to be a semicircle, and the measure is always going to be 180. If it's 181, then it is a major arc. If it's 179, it's a minor arc. Semicircles are only 180 degrees. Minor arcs are named by their endpoints. For example, in this circle here, we have AB. So if I were to highlight this arc right here, this would be arc AB. It is a minor arc because it is less than 180 degrees, and it is designated by a small arc over A and B. Let's see if I can do that a little better. So that's minor arc AB, and it always has only the two variables to designate a minor arc. Major arcs and semicircles are usually named by endpoints and another point on the arc. In this case, they have this point D here, so they're talking about A goes through D and ends at B, so it's arc ADB. And this is a major arc, and it will always have three variables determining what this arc location is. The degree of measure of an arc is the measure of its central angle. So when I look at this one, I see that this measure of this arc is 50 degrees, and that means that the measure of this arc is 50 degrees. Okay. Measure of an arc formed by two adjacent arcs is the sum of the measures of the two arcs. So if I have, let's say I put this one here, and just say, let's say it's 30 degrees. So I would have 50 plus 30, that would be 80. So from A to E, this minor arc would be 80 degrees. Okay. If I wanted to find what the measure of ADE, I know that if I have a full circle, I have a 360 degree angle. And if I want to find out what just this section here would be, I would subtract 50 from 360 and get 310. So that means that my major arc ADB is 310 degrees. So we could use what we know to find out what our angle measures are, or our arc measures for degrees. This is important. Circles are congruent if they have the same radius measure. If they have the same radius, so if I were to draw another circle, and I tell you that my radius is the same, so let's say that this is 4 meters, and I say this is 4 meters. That would make these two circles congruent because they have the same radius measure. They are exactly the same distance from center to the outside point on the circle as the other. Arcs are congruent if they have the same measure and are the arcs of the same or congruent circles. So if I said that I had there, and let's go Y and Z, and that I said that, let's get rid of that 4 meters, move it out of the way, and said that this was 50 degrees and that it had a 4 meter radius, then I'm saying that these arcs are congruent because it's 50 degrees and it has the same size radius. And there's a couple other ways that we're going to see later. So if the circles are congruent and they have an arc that has the same measurement, then the arcs are going to be congruent. Okay? Let's take a look at some of these. Let's find the measures of each arch of circle P, where RT is the diameter. So here's our diameter, here's a radius, and then we have this angle that has 110 degrees. And they want me to find the measure of the angle of RS. So RS would be this section right here. And we know that if the central angle is 110 here, then this is also going to be 110 degrees. If I look at the angle RTS, we're talking about a major arc. And we know that the entire arc, the entire circle is 360 degrees. If I want to know what this section is, I would take 360, and I'm going to subtract 110 from it, and I'm going to get 250 degrees. RST, so RST would go from this point around to this point, and we know that the two endpoints are the endpoints of the diameter, so that means that this is a semicircle, and it would equal 180 degrees because semicircles always equal 180 degrees. Our final one is minor arc ST. So we're talking about this arc right here, and we don't know what this measure of this arc is. But I do know that if I go from here to here, I get 180 degrees. So if I just want to find this little piece, I can take this from 180 degrees to find out my unknown. So I'm going to take 180 minus my 110, and I'm going to get 70 degrees. So this was a minor arc, this was a major arc, this was a semicircle, and this is another minor arc. All right, let's start learning how to find the length of the arcs. You're able to find an arc length using concepts of circumference, using the same reasoning results in the formula for finding the arc length. And remember, circumference of a circle is 2 times pi times radius. And so as long as we have a radius, we know that we can find the circumference of a circle. The arc length, we're going to call S, of an arc with a measure of m degrees and the radius r is given by the formula the arc length equals the measurement of the degree over 360 times 2 pi radius. And so we're going to use this formula as much as possible. We do know that circumference is also pi times diameter, but if it gets too confusing to remember which one to use, always find the radius and use this one. This one will get you there every time. All right, let's take a look at finding the arc length. It says on a clock face, the minute hand of a clock is 10 inches long. To the nearest length of an inch, how far does the tip of the minute hand travel as the time progresses from 12 o'clock to 12:15? So here's our clock, and we see that our minute hand goes from the center of the circle to the edge of the circle, and so that means that my radius is going to be 10 inches. And they're wanting to know how far does the tip of the minute hand travel as it goes from 12 o'clock to 12:15. So we're starting here at 12 o'clock, and we're going to end here at 12:15. So let's go ahead and draw a line there so that we can see our arc. So we need to know what the degree, or the measure of the degree is of this vertex. So when I do that, I know that if I go from 12 to 12:15, it's 15 minutes. If it goes all the way around, it's 60 minutes. So I'm going to take my 15 over 60, and I can simplify that to 1/4. Now 1/4 of 360 going all the way around is 90 degrees. So that is our measure of the central angle. Now we can use this information, now that we've discovered it, we can use that in our formula that we have up here. That is the measure of the arc is the measure of the degree of the angle over 360 times 2 times pi times radius. And we've identified our radius and we've identified our central angle. So what we're going to do, I'll do it over here off to the side, is we are going to find our S by taking our 90 over 360 times 2 times the pi button times our radius, which we know is 90. 10. Okay. So what we're going to do is we're going to go ahead and put in our calculators 90 divided by 360, and I get 0.25 times 2 times 10. And the reason I skipped pi is because the commutative property says I can do this in any order I want. And I want to find it in the terms of pi, which means we want to keep pi in our answer. So when I do this, I take 90 divided by 360 times 2 times 10, and I get 5, and then we bring down our pi. So this is called terms of pi. It's leaving the pi symbol in. Now, if they want to simplify it further, then we're going to take 5 times the pi button, and we see that it is 15.70796 and so forth. And so typically we round to the nearest tenth unless I'm told otherwise. So this would be 15.7, and the radius was in inches, so it is 15.7 inches. So from here to here, we traveled 15.7 inches. Okay, let's try another one. It says the minute hand of a clock is 6 inches long. To the nearest tenth of an inch, find how far does the tip of the minute hand travel as the time progresses from 12 to 12:30. So there's a couple things we can pick from this. We see that the minute hand is 6 inches, and we know that's going to be our radius. And then we need to find our central measure. So if I look at 12 to 12:30, well, I know that that's 30 minutes. So that's half an hour. So if I take half an hour times my 360, I get 180. So my angle degree of that arc is going to be 180 degrees. So let's go ahead and plug that into our formula. So we have our arc length is going to be 180 over 360 times 2 times pi times our radius, which we said was 6. And so now we're going to put that into our calculator, and we're going to take 180 divided by 360, and that's going to give us 0.5 times 2 gives us 1 times 6 gives us 6. So in terms of pi, we get 6 pi. If I were to simplify it even more and take that 6 times the pi button, I'm going to get 18.849. And it said to round it to the nearest tenth. So it says here 1/10 of an inch. So we're going to take 18.8, and that was in inches. So we're going to get 18.8 inches for the length of the arc from 12 o'clock to 12:30. Okay, let's try this your turn. It says the minute hand of a clock is 8 inches long. To the nearest inch, 1/10 of an inch, how does the tip of the minute hand travel as the time progresses from 12 o'clock to 12:45? Well, the first thing we need to find is, what is our radius? So my radius is 8 inches. Now I need to find my central measure of my arc. And so if I look at the time, it goes from 12 o'clock to 12:45, and I know that's 45 minutes. 45 minutes out of 60, if I simplify that, is 3/4. So I'm going to take 3/4 times 360, and I'm going to get 270. So my measure of my arc is 270 degrees. Now I'm going to use this, and I'm going to find the length of the arc from 12 o'clock to 12:45. Remember, the length of the arc is your measure of your angle degrees over 360 times 2 times pi times my radius. Okay. Go ahead and try this one and check to see what your answer is. In terms of pi, I get 12 pi. Now if I were to simplify that more, what would it be? So if I take 12 times pi, I get 37.7 inches. And what I did is I got 37.699, and it wanted it rounded to the nearest 1/10 of an inch. So that's how I got my 37.7 inches. All right, let's practice a couple more. All right, number 5 says find the arc length of arc AB to the nearest 1/10. And so what I like to do, and it just helps me visualize, is to draw my arc or my angles. So this is 90 degrees. And I want to find the length from A to B. I see that my radius is 20, and I have my M. So my radius is 20, and my measure of my angle is 90. And so I'm going to use that to find to the nearest 1/10, find it in terms of pi and in decimal form. You should have set up your equation as 90 over 360 times 2 times pi times 20. I took 90 divided by 360, multiplied it by 2, multiplied that by 20, and I got 10. So my answer in terms of pi is 10 pi. Then I simplify that even further by taking 10 times pi, and I get 31.4, what I round to the nearest tenth, and that would be in meters. So terms of pi and my simplified form. Take a look at number 6 and find your radius and your measure of your angle degree. Okay, at this point you should have found that your radius is at 3, not 30, and that your measure of the angle degree is 120. Go ahead and find your answer in terms of pi and in decimal form. Okay, you should have found that the radius is 3, the measure of angle is 120. Set it up in your equation. The terms of pi would be 2 pi, and in simplified form it would be 3.6 inches rounded to the nearest tenth. We've already done one that was at 180 degree for this portion, and then try 7 and 8 on your own. Please see your teacher if you have any questions.